Hello and welcome to CS264 Software Design. This is lecture 8 and this is lesson 1. In this lesson we're going to talk about delegates and C#. Now a delegate, that's a type that represents references to methods with a particular parameter list and return type. In other words, the method's signature. So when you instantiate a delegate, you can associate its instance with any method with a compatible signature and return type. Then you can invoke or call the method through the delegate instance, and reference can be changed at runtime. Remember, delegates are object-oriented, type-safe, and secure. So C# delegates then are similar to pointers to functions in C or C++, if you use those languages. They're often used for implementing events, which we'll see a bit later, and for setting up callback methods. Delegates are implicitly derived from the system.delegate class. Okay, so a delegate object then, that's normally declared by providing the name of the method of the delegate will wrap or using some anonymous function. So once a delegate has been instantiated, a method call made to the delegate will be passed by the delegate to that method. So the parameters passed to the delegate by the caller are then passed to the method, and the return value, if any, is returned to the caller by the delegate. In other words, this is invoking the delegate. An instantiated delegate can be invoked just as if it were wrapped, the wrapped method itself. So there are 3 steps associated with using delegates. First step, declare the delegate. Second step, instantiation. So that's instantiate the delegate and set some target method. And invocation then is the third step, just that means you invoke the delegate. Again, delegates are declared using the delegate keyword, followed by a function signature as shown below. So we have some modifier, that's an access modifier, delegate, what the return type is, the delegate name, and the parameter list. In other words, the signature and the return type that you will need. Okay, so in order to work with delegates in C# then, I have a little demo program for you that shows the different ways to go about delegate declaration, instantiation, and invocation. These are the 3 things you need to know. So the example uses static functions here. And we'll see an example of using a member function invocation later. So my program is called MyDelegates, and you can find it in the list of programs, in the demo programs that I have available for you. And they're here somewhere. You can see MyDelegates. Okay. So we set up a delegate, declared a delegate. So we use delegate keyword to do this. Public delegate, void MyDelegate, string text. So here's the name of the delegate. Here's the return type. And here's the parameter list, or the signature. Here's my other delegate called indexInt y is the parameter list, and again it's a returns event. Okay, so we just have a simple program here. We have static method. Let me have a quick look and see what we do. Oh, here are the functions that are going to be used. They said they're static. Here's a static void my string 1 is a string s. My string 2 is a string s. Here's a static int sum, something that returns the 2 of these, and something that returns the product of these 2. So we have 2 different kinds of void methods that take a single string as a parameter, and 2 methods that return an int and have 2 ints as parameters as well. So we really interested in looking at methods that we can assign to these delegates here. Okay, so here's a delegate, d1 my delegate, and we're telling it it's going to refer to string 1, and then we can just invoke the delegate. So it should say it's string 1, create a new delegate, okay, and assign it to d1, and then invoke that one again, and then we just wait. Okay, so we can see this running. Get running. In fact, we could have just run it from the command line, I guess, but let's do it here in case we want to look at the code from here. Okay, and so again, what happened is that we assigned a method to the delegate, executed it or invoked it, got a hello from delegate, and then hello again. So it was from string 1 and string 2, so 2 separate methods. So that was fine, and we expected that. Okay, so let's have a look then. So we have another delegate here called my other delegate, and this again works with the sum, okay, and the product. Okay, so again it's the same thing working again with these methods, and we can see it running, and we essentially called the delegate again. We could also instantiate the delegate this way. Okay, we could just say my other delegate D3 is assigned value of sum, so it picks it up that way, and we can just assign product. So we don't have to, as long as the method signature is the same, it works just fine. Or we could use an anonymous method. So here we create a new delegate called D4, and then we're creating a delegate like this. Okay, we have some anonymous method that's been created here. Okay, and it works fine. Okay. And again, we could actually use a lambda expression to create it as well. So we have my delegate D5, and has a parameter text, and we're able to just have another anonymous method inside the lambda here, and then we can evoke that method. So there's lots of ways in order to be able to make that work. Okay, here's an example. I suppose we could just have a quick look to see that those demos worked, the anonymous methods, and the lambda that worked as well for us now. Here in this example, we have a single delegate mapped to a static method and then to an instance method. So in the examples here, these were all static methods here. Okay. So now we have something called my other delegates. There's another program I've written for you, and you can have a look at it. So we declare a delegate called my delegate, and it's got the void type. The parameter list is empty. Now I have a sample class here, my instance method. And you can say, it's just a message that says hello from this instance method, but you'll see that the signature here of this method is void as a void type, the same way as the delegate, and the parameter list is empty, the same way as the delegate. So we can make this, after we declare the delegate, which we do down here, then we can actually assign this particular method here. So here's another method, another static method this time. So we had an instance method, a member method, and we have a static method. They both do the same. So the instance method, static method, they've got the same signature, same return type, so we can call them. So my delegate D, we created an instance of that class, SC, that sample class, and we execute the method again here, and we execute it again using d.invoke this time, because we can use invoke rather than just call the method if we want to explicitly invoke something. So that works very nice. There's two ways of doing this. Another thing that's interesting, of course, is to be able to work with multicast delegates in C#. So a very useful property here is that multiple objects can be assigned to one delegate instance by using the plus or the plus equals operators. So this is called a composed delegate or a multicast delegate. And that contains essentially a list of the assigned delegates. So when a multicast delegate is called, it invokes the delegates in the list in order. And only delegates of the same type can be combined with the multicast delegate expression. And we can use the minus or minus equals operator to remove a component delegate. So we have a bunch of methods. Here's an example in my other delegates, and you can check this application and see it running here. You can see I have one written for you, my other delegates. I think it probably just gives you the example that I did last time, and then I combined the rest of them here. So we can have a whole bunch of messages coming from the various methods here. And what's happening is that I'm chaining all of these method calls together, essentially, into a composed delegate and creating this multicast delegate system here. So let's look at how it works. Okay, so I have my delegate. It's very simple. Does nothing. No parameter. It doesn't process any parameters. Has a void return type. So here's an instance method. And here's a second instance method, and here's a static method. Now, all of these three, the two instance methods and the static method, have a void return type and have an empty parameter list, so they can be assigned really to this particular delegate here. Okay, so now I've created a class, because I just wanted to get the access to those items here. And I can get my instance method here. So I've created the delegate instance. I've assigned this method to it, okay, and I've invoked the method. Now what I've done is I'm mapping the static method and I'm invoking it. So I'm overwriting it. Now I'm creating three separate delegates. Okay, so the first one takes an instance method, calls it, adds a second instance method, adds a third one, this is the static one, and subtracts the last one and executes these. So I'm creating this, I'm using this plus and equal to operators here in order to be able to make the composed delegate. Okay, so it's nice to be able to do that, and you can see that's happening here. Okay, So if a delegate returns a value, then the last assigned target method's value will be returned in a multicast delegate. So for example here, if we have this simple, my multicast delegates, I don't know if I created this one. Let me see. No, I didn't actually give you this. You can write this yourself. You can copy and paste. Okay, so with this multicast delegate, what I'm able to do here is I've created two classes, class A, and I have a static method in here, and class B, again, a static method with a single method, method B, one returned the value 0, one returned the value 1. And I was able to not add these as such, I was composing the delegates here, okay? And then I'm writing D1, and if I just compose the delegates in a way where I have D2 and D1 and the return values, I get D1, and then I'll be able to see what happens here, okay? Okay, that actually should probably, shows the value of doing this. I probably should have said D here, not D1, but that's why I didn't write the code, and it just shows you the value of writing code every time. Okay, where is it? It's here. Okay, I should be writing D here, I guess, and D here. Okay, so that works. Okay, very good. Okay, so we can work with generics as well when we're dealing with these. So you can essentially create generic delegates. So they're defined the exact same way as a regular delegate, but to use the generic type parameters or return types. And the generic type must be specified when you specify the target method. Okay, so here's a public delegate T addition on this type T with taking these two type parameters of type T. So this is your list, parameter list. And so really what I'm doing is I'm defining a sum method on two integers here, and I'm defining a sum method on on strings here in terms of concatenation here. So here I'm assigning, creating a delegate, okay, called here, just delegate, so delegate addition, and I can use the addition to essentially assign the sum for integers method to the delegate sum, and I'm now assigning, using the same delegate definition essentially, but with a string type this time, onto concat, and I'm assigning it to the value of concat method here that does summation, or essentially concatenation, and I'm just reading. Okay, so it's nice. Okay, so we learned about delegates in C# in this particular one. We can really check out the documentation if you want to have further examples using delegates. There's some great examples online if you want to search for delegates in C# using your favorite search engine. I listed a really interesting one down here by Scott Hannon about how and why to use delegates in C#. It's really, really good. Yeah, definitely worth reading. Okay. And thank you very much for watching.